I see. All right, so when you're looking at these, what makes these different than, so think back to your quiz yesterday. We had 4 of them on the top half of the second page, and then 2 of them were like this. What makes these a little bit different and a little bit more challenging than the first trinomials that we started to factor? Matthew, you've got a number in front. Why does that make it harder? More work, but why? Why does it give you more work? Montreal?
Because it could be like more than one.
Yeah, exactly. There's more than one option now for what it could be. As opposed to when it was just something like this, where it was like x squared plus, give me a number between 1 and 10. 5x plus 6. When it was like this, all you had to do was say, what multiplies to 6? That gives me 5, right? So you knew what would that have to be. Yeah, so it'd have to be x plus 3, x plus 2. When you throw a 2 in front of here, all of a sudden, what happens to one of these x's? Yeah, you have to make it a 2. So it gives you a couple different options. Now, for the most part, how many of you guys got, like I think everybody in here did number 1. How many of you guys got it on the first or second try? Most of you got it on the first, most of you did. I watched all of you do it. So most of you got it on the first or second try because 2 is what kind of number? Prime. And prime numbers mean how many options did you have with that? Only the 1, right? You could only do 2x times 1x. There's no other choices. And then which numbers did everybody pick? Everybody did this, which was interesting. For 15, what did everybody pick? 5 and 3. Your gut reaction is typically what's going to be right. So when you look at something like, look at number 3, what's your gut reaction for what gives you 27? 9 and times 3, right? That's probably going to be the one that will work. So go with your gut when you're thinking of what do I try first. Try the ones like that. It's typically not going to be 27 and 1. All right? Unless this number in the middle is really, really big, it's probably not going to be that. Okay? All right, so go with your gut on those, and that will kind of shorten the amount of work that you have to do. But like Matthew said, it is more work to do these because there's a number in front. It doesn't mean they're impossible. It just means there's more work. I did tell you, though, and I promise that this is true, we're never going to get bigger than 6, and typically this one will stay down below 4. So there will only be a limited number of options. Again, I don't want you guys to spend 4 hours trying to figure out a factoring problem. I want to know that you know how to do it, and then I want to move on. Okay? All right, so we're going to talk about a couple special cases today. They're special trinomials that include perfect squares, and that means they're going to factor in the same pattern every single time. So before we talk about these, we need to refresh our memory on what a perfect square is. So what is a perfect square? What's a perfect square? It's something that you can take the square root of, right? So like 81, is that a perfect square? Yes? Why? Because 9 times 9 gives you 81. Is 100 a perfect square? 100? Yes. 10 times 10 is 7? No. Why not? It's a prime number. And if you took the square root of it, what kind of number would it give you? A decimal. So a perfect square is a number that when you take the square root, like Angel said, you get a whole number. All right? So when we're looking at perfect square trinomials, that means the parts on the end, the a and the c, are perfect squares. So again, when we're talking about A, we're talking about this thing, and when we're talking about C, we're talking about this term. So A is the first term, C is the second term. Again, the B just kind of falls into place, okay? So the B comes from when you add it all together, but the A and the C are what we're really concerned with, because the A is where you get this one from, and then the C is where you get your second terms from. Okay, so we're going to talk about perfect square trinomials, and then we're going to talk about difference of square trinomials. And the reason that we're talking about these is because if you recognize the pattern, they become really easy. All right, so before we start, if it's a perfect square, that means the number has to have a square root. What about an exponent? If it has an exponent, when is the exponent a perfect square? So for instance, is x squared a perfect square? Why? What gives you x squared? X times, okay, good. Is x4 a perfect square? Yes, what could you multiply to get that? X, two things, x2 times x2, good. Is x6 a perfect square? Yes, what would it be? x3 times x3. Perfect. x3 times x3. Do you notice anything about those exponents? If you, yeah, you add the exponents and that gives you this one. Do you notice anything that these three have in common? They're even. Will it work with an odd one? No. Because if it were x7, for instance, that would be like x3 and x what? 4. And that's not a perfect square because these two things are not what? The same. A perfect square has to be the same. So odd exponents cannot be perfect squares. If it has an exponent, that means the exponent has to be even. So I'm going to erase this, maybe. Yes. All right. Now, exponent has to be even. So of all of these, which of the following are perfect squares? Raise your hand if you can come circle a perfect square. Remember, the number has to be a perfect square, the coefficient, and the variable's exponent has to be even. Brendan, come up and do one. Anybody else? Good. Matthew? Circling the perfect squares. Diego? Is 2 a perfect square? What times what gives you 2?
Oh, it's a prime.
Yeah, so 2's not, but is there another one up here that is? Which one? Good. All right, Diego, what do you think? I see 2 more.
Oh, yeah.
Ollie? Yeah, x squared is a perfect square. Do you want me to do it for you? You want to come on? All right. So x squared is also a perfect square. So these are all our perfect squares. How come this one isn't? Because 9 is a perfect square. Oh, x to the 3, so that one can't be. Okay, what about this one? 2 is not a perfect square. It's a prime number because you'd have to do 2 times 1. You couldn't do something times itself would not give you 2. Okay, and then 45 is not a perfect square because nothing times itself gives you 45. So those are our perfect squares. There are more, but those are the ones that are on this board. Can you guys give me, like, what's another perfect square? Give me something bigger than 50. What's a perfect square bigger than 50? 144, 100, 81, 64, 225, 256, 125. All right, the ones you should know probably go up to 12. All right, so you should probably know up to 144. 13 is 169. They use that one a lot too. Okay. So when you have a perfect square trinomial, that means that A and C are perfect squares. So looking at this first one, is A a perfect square? Yes, because x squared breaks down to what? X times x. Good. Is C a perfect square? Yes. So then this is a perfect square trinomial. All right? A and C are perfect squares, so it's a perfect square trinomial. What about the second one? No, why not? What's not perfect square? 2x squared is not a perfect square. So we would say this one is not a perfect square trinomial. 81 is, but 2x squared is not.
How is 2x squared not a perfect square?
Because what gives you 2? Nothing. Nothing that's the same, right? You would need something like 2 times 2 gives you 4, 3 times 3 gives you 9. Nothing times itself gives you 2. The only thing that gives you 2 is 2 times 1.
But x2 is a...
Yeah, but that's x times x. This is an exponent of 2, which is different than having a coefficient of 2. Good question, though. All right, what about number 3? Yes, because 4x squared is a perfect square, 9 is a perfect square, so that's a perfect square trinomial. Now, why do we care? Because perfect square trinomials factor really easily. So perfect square trinomials can only factor one way. When I'm looking at this, I have a couple options for 4, right? What are they? 4 times 1 or 2 times 2. But since this is a perfect square trinomial, then that means I'm going to have to use which one, do you think? 2 times 2. So it's going to be 2x times 2x. And now I'm looking at C. Is that a perfect square? Yes. What could give me 9? 3 times 3 or 9 times 1. But since it's a perfect square trinomial, which one am I going to use? 3 times 3. Okay, now this should not be, this should be 12, sorry. That should be 12. All right, so every time you've got a perfect square trinomial, you just break down the first one and the last one, and those give you your parts. So for example, if we had, give me another perfect square, anyone. Give me a number in front of it. 4? Okay, give me a bigger one. Perfect square. Perfect square, 16x squared. All right, 16x squared, and then give me another one.
20.
Good, perfect square, guys. 81. All right. Okay, so I'm looking at this, and right now this looks huge, right? That looks like I got a lot of options for 16. I got some options for 81. There's a lot to figure out. But is this a perfect square? And is this a perfect square? So then what's it going to have to break down to? This has to be 4x and 4x. And then this has to be 9 and 9. All right? And then 9 times 4 is, and 9 times 4 is, and 36 plus 36 is 72. Okay? So when it's a perfect square trinomial, you just have to break down your A and your C, and you don't need to worry about the B. So there's no tons of options that it could be. As long as they're perfect squares, it's going to break down. What do you notice about your two binomials? They're identical. Okay? They should be identical to each other. Because a perfect square means you're multiplying what? Something times itself, right? So a perfect square means you're multiplying something times itself. So your binomials have to be identical. Okay. Try those at your seats. This should be 8. And this should be 10. No, you got to factor them. All right, I want to give you guys 10 more seconds, and then I need a volunteer for number 1 and a volunteer for number 2. What's different about number 1?
Negative.
It's a negative 12? Yeah, it's a negative 12. So what do you think that means for your answer? Both of them will be minus? Good. Okay. So then what would this one be? Somebody, Ash, what do you think? Do you want to come up? Yeah. So is it a perfect square trinomial? Yes, because 4x squared is and 9 is. So then you know it's going to break down the same way. So your binomials should look identical. So Ash, what are they going to be?
2x
Good.
and 2x.
Good. So those have to be the same.
And then to get a 9, it's 3.
Good.
So -3. And -3.
Perfect. And then just to check yourself, are they identical binomials?
Yes.
Yep, so then you're all good. Okay, what about the second one? What about the second one? Ollie.
Did I just write it down?
Yeah. Perfect. Great job. All right. So at your boards, before you go up there, for the first two, you're actually factoring them. For the second two, you're just saying why it is not a perfect square. So you have to explain why it is not a perfect square. Go. Okay, so all of these are perfect square trinomials because they all are going to give you identical binomials. So the last thing we're going to talk about is when you have a difference of two squares. So before we move on, what does difference mean? Difference is what? Means it's going to be a minus. Difference of two squares, this is a difference of two squares problem because it's a subtraction problem, and both of these are what? Difference of two squares. So what do you think both of these are? Difference of squares. So that means both of these must be
Negative.
What are these things? This is x squared and this is 9. So they are, what have we been talking about? They are perfect squares. They are perfect squares. A difference of 2 squares just means it's a difference problem, so it's a subtraction problem, and both of the terms are perfect squares. All right, so this is a difference of 2 squares because both of them are perfect squares. Now, you guys had one like this on your quiz yesterday, but you did that before you knew what this was. That question is a lot easier now that we're talking about this. How do you know, like basically this should give you a trinomial, right? But it doesn't have a what? It's missing the what? It's not a trinomial, it's missing the middle stuff, right? So what happened to make it go missing? It canceled out, right? It canceled out. So when do things cancel out in math? When they're the same number, but one is negative and one is positive. So when you're factoring a difference of 2 squares, that's what happens here. It's essentially the same binomial, but one is negative and one is positive. So what would give you x squared? X and x. And what would give you 9? 3 and 3. But because it's a difference of squares, one has to be positive and one is negative. Because look what happens when you OI. Outsides, insides. What's x times negative 3? And what's x times positive 3? What happens with these two? They're gone. So that's why this works. That's why a difference of 2 squares is easy to factor if you can recognize it, because they're identical except for the signs. So like our last ones had to be totally identical. These are identical except the signs have to be different, because what has to happen to the middle two? They have to cancel out. Okay, so if our difference of 2 squares, give me a perfect square. 16. All right, give me another perfect square. 144. Okay, try to do this difference of squares. Can I keep him for like 5 minutes and then yes? Is that okay? Okay, great. Okay, so looking at this problem, is the first one a perfect square? Yes. Is the second one? Yes. So we're just breaking it down, except the binomials are going to have what kind of signs? One is plus and one is? Okay, what's going to give me 144? And then what's going to give me 16x4? 4x2. So then this has to be 4x2. All right, now I can check it. 4 times negative 12 is?
Negative 36. Oh my God.
4 times negative 12. Negative 48. And then 12 times 4 is 48. So what happens to those two? They cancel out. So that my OI canceled out. So then I'm done. All right? Thanks. So how do you recognize a difference of 2 squares? First of all, there's nothing in the middle. All right? It's what kind of problem? Negative subtraction problem. And both terms have to be what? No, they could be the same, but they have to be perfect squares. Down here, yes, the signs have to be opposite. Good. In your binomials, the signs have to be opposite. Okay. All right, so what would this first one be? X and x, and then what? Minus 6. Perfect. What about this one? 3x. And then plus 5, minus 5. Perfect. I'm not even going to check them because I know that they're difference of squares, so I can trust that I'm right. All right? So you recognize these because there's only 2 terms, but make sure that they're perfect squares because these have to be identical except with different signs. Okay, go do these 4 at your boards. Montreal.